of x is equal to negative 2x cubed plus 5x plus 8. All right, with that polynomial function, we're going to first off decide whether or not it is a function, and I know that because this is written in function notation. Remember, f of x is the same as y, but they sometimes use f of x to tell you it's a function. So I'm going to try to decide if this function is a polynomial function. Okay? Then if it is, I'm going to write it in standard form. So that's one of the things that we're going to be talking about, standard form. I'm going to tell its degree. That one might be a new one for some of us. And its type, what type of polynomial function it is, and its leading coefficient. Alright, so everybody good? Alright, to check and see if it's a polynomial function. First off, polynomial just means several terms. You got a monomial that has one term, a binomial that has two terms, a trinomial has three terms, so polynomial is just several terms, okay? So then from that, what I'm going to look at is exponents. Okay, things that cannot happen in a polynomial function. Its exponents can't be negative, and its exponents can't be variables. They've got to be whole numbers, positive whole numbers. So on this, I've got right there, I've got an exponent of 3. That's a positive whole number, right? What's the exponent on this x? 1, and that's a positive whole number. So yes, it is a polynomial function because I didn't have any negatives or variables. So yes, it's a polynomial function. Then from there, my first thing on my list over there, if you didn't see, I left a C out. First thing on my list over here said to write it standard form. Standard form just takes your highest power and goes in descending order. That means greatest to least. That one already is, right? My greatest power is 3. Then I got a 1, and then I got a constant. So 3, 1 constant. That's already greatest to least. So it's already in standard form. Check. Sometimes we'll have to move them around. Alright, degree. The degree of a polynomial function is your highest power. So this would be a degree of 3, because 3 is my highest power. Right?
What's your highest, the power means So if you just had like negative 2x, it would just be 1.
Alright. Now that has a special name for type down there. Our degree is third power. That means it is cubic. I'm going to make you a list of the different names of them here in just a second. But since our degree was third power, that means it's a cubic polynomial function. Then our leading coefficient. The leading coefficient is, coefficient means number in front of the variable. Leading is the one of our highest power. So our highest power was 3. The leading coefficient there would be negative 2. Alright, so we'll make you a little chart here, and then we'll do some more of those before we get into some other stuff. Make that way.
How do you know it's a polynomial function again?
Because I did not have a negative exponent or a variable exponent.
You figure it's a cubic type from that cube?
From the degree. I'm fixing to make you a list of those, David, so that's what we're fixing to look at. Alright, here are just some common, and this isn't all, this is just some common polynomial functions. P-O-L-Y-N-O-M-I-L. Okay, I'm going to make a column that's got a degree, a type, standard form, and then I'll give you some examples. Alright, we could have something that has a degree of 0. If it has a degree of 0, that means it's a constant, because it's not going to have a variable. Okay? Standard form of that, if I write this would just be f of x is equal to a base 0, for example. Okay, now the reason that's a constant with a degree of 0 is because if I plugged a variable in on that, remember the power, the degree is always on the variable, so that would have to, if I use that negative 14 example, what's anything to the 0 power? You had that on the bell ringer last week. It's just 1. So negative 14 times 1 is just negative 14. So that's why anytime you've got a variable to the 0 power, it's the same as just 1, so you're not going to have a variable. If you don't have a variable, it's just a constant. Okay? 0 power thing was on a bell ringer last week. Alright, if we got a degree of 1, the highest power is 1. We are linear, which means our graph is just a line. We have f of x equals a base 1x plus a base 0. That's kind of more confusing than just the example. 5x minus 7. I'd probably just go to the example column instead of all that.
Since you have like the 1 and 0 at the bottom, what does that mean?
Yeah, it's just
not
a-
an exponent? Or?
No, it's not exponent, it's just another, you could put any letter there you wanted.
Oh, it's like when you have like x1, x2.
Alright, second power, or degree, that's what we did all for the last month. That's a quadratic. Quadratic. We have f of x equals, has to be squared in a quadratic, right, plus, and all it's doing is building on these up here. a1x plus a0. Good example, and it'll be 2x squared plus x minus 9. A base 2x squared plus a base 1x plus a base 0. And that a base 2, a base 1, a base 0, that's what Macy was asking about. That could just be, that stands for any number. And it could be anything in there.
Is it basically saying that it's not the same?
Right.
The A's aren't the same?
Right. But they really even could be the same. But yeah. Alright, the third degree is the one we did just a second ago, and you were right, it was cubic. Cubed, something to the third power you say is cubed. So we're just going to add a cubed here to our standard form. Be f of x equals a base 3x cubed, and then you still got all that other stuff. A base 2x squared, a base 1x, a base 0, and then I'm going to say x cubed minus x squared plus 3x. That's a good one.
Would it still be cubic if you had like a plus 7 at the end?
Yeah, put a constant on it, yep. So the way I wrote it, what would the constant be?
0.
Yep. Alright, because this is the same plus 0 if I didn't put a number there, right?
Oh, yeah.
Alright, fourth degree. That one is called quartic. Q-U-A-R-T-I-C. So we're just going to add a fourth in that. So f of x would be a to the 4, x to the 4 plus a base 3 x cubed plus a base 2 x squared plus a base 1 x plus a base 0. Q-U-A-R-T-I-C. I skipped several in that example, didn't I?
So does it not have to have all the, it just has to have the four? So the first one determines it?
The highest one determines it. We're fixing to have some that are scrambled up. And it's being standard form, it's highest to lowest, so we'll have to rearrange it. But it doesn't have to have every one. If you're asked, like, what would the third to the, what would the cubic term in that one be? It would be 0. Because you don't have anything to the third power.
Okay, if it is like scrambled up, you have to like subtract it. You just
No,
move
because
it
they're
around.
all on the same side, so you can just move them around. Alright, let's look here at some more like we started off with, and I got what you need off that beauty. Alright, I got g of x negative 0.8x cubed plus 2 square root of 2 x to the 4th minus 12.
Is the x to the 4th under square root?
Nope, just 2.
Is that a point?
Yes, negative 0.8x cubed. Alright, so first thing that we answered on the last one that we're going to answer here is this a polynomial function? So to test on that, I'm looking at my powers. I got a third power, that's not negative and that's not a variable. Right, it's just a 3, that's so good. I got a fourth power, it's not negative, it's not a variable, it's just a 4, so that's good. So yes, it is a polynomial function. Polynomial fun. Okay, after that, we need to write it in standard form if it's not. Standard form just takes your highest power first. So is this one in standard form? No, so we just got to move it around, change stuff around. We're not jumping over the equal sign, so we don't have to do opposite operation. We can just reorder it. So I need this square root of 2 x to the 4th to be first, and then next will be the third, and it's a negative, so minus 0.8x cubed, and then my constant would be last. So there is standard form.
Oh, so that x isn't under the square root.
Nope. Alright, so we got it in standard form. Degree, what's our highest power? 4. I mean, that should 4 is bigger than 3, right? So degree is 4. What was the type when it was a fourth power? Quartic. And what's our leading coefficient? That's it. Pretty simple stuff. Break out what you need on that? Good, good, good. Alright, look at these two. We'll give you 2 for 1 right now. I got h of x is equal to negative x squared plus 7x to the negative 1 plus 4x, and then I've got k of x is equal to x squared plus 3 to the x. Neither one of these is a polynomial function. They are both not polynomial functions. Not polyfun. Not polyfun. Why? Okay, this one's got a negative exponent, and that one has a variable exponent. Now, if they're not polynomial functions, you don't have to do any of that other stuff. You don't got to answer any of those other questions. Yep, that's it.
If we have this on the test, should we just point out why it's not a polynomial?
Oh, if they ask you to, yeah, but so let me see if this one said to decide whether it's a polynomial function. If so, so it didn't tell us to say why on that one. Alright, other thing that we got to do, which there's several, but the next thing that we got to do is we got to evaluate some polynomial functions. So if I gave you one, this one says f of x equals 2x to the 4th minus 8x squared plus 5x minus 7. We're going to evaluate that for something in just a minute. That's 8x, negative 8x squared plus drop down there. We're going to evaluate that in just a second, but before we do, I want to make sure we understand all those definitions. Is that a polynomial function? Yes. What's its degree? 4. What's its leading coefficient? 2. What do I call a fourth degree? Quartic. So we're good on all that stuff. All right. We're going to evaluate this when x is 3. So it's pretty simple. Some people will say if I'm evaluating for x is 3, they're going to say f of 3 is equal to. Now I'm just going to plug a 3 in everywhere there's an x. Okay, 3 to the 4th, 3 times 3 is 9, times 3 is 27, times 3 is 81, times 2 is 162, 3 squared is 9, times 8 is 72, 5 times 3 is 15, minus 7, 2 is 2 is 0, 6 minus 7, I think that's 9, so it'll be 90, plus 15 minus 7, so that's 105, minus 7, 98.
So I got into
Those are the pretty simple ones to do. Y'all can get that pretty easy. It's just order of operations stuff. Yes, so that'll be the correct way to write that. You're right, Rose. F of 3 was 98.
Wait.
What? What's matter?
Why can't we divide by 3 and 3?
What's matter?
How'd you get 162?
3 to the 4th times 2. How'd you get?
I didn't know.
Well, remember, power, order of operations, power comes before multiply. So you would do 3 to the 4th first.
I didn't know if you had to do like 2 to the 4th and then like add them together.
If the whole thing had been in parentheses, I would have, but
Oh.
just on that 3 is all that got the 4th power.
Right.
Yes, David?
Do you have like parentheses in the next column, like that 2, 3, 4? Would you multiply 3 by the 4th power?
3 to the 4th power would come first, yes.
And
And then multiply what you got by 2, yes, sir. Now, your order of operations, exponents comes before multiply. Please excuse exponents. So that comes first. All right, need to make a little chart here about end behavior of polynomial functions. So we'll look, D-E-H-A-B. Oh, set it up. We're going to have 4 pieces on it, so however you want to make it there.
And behavior
so what?
I do like a chart there. How much room do I need for this?
Half page.
Oh, shoot. Okay. Okay.
Graph will need to be half a page?
We're fixing to put a lot of stuff in there.
Okay.
I mean, I could tell you smaller, but then y'all whine and say you didn't have enough room. So not that y'all would ever do that. Just starting off with degree and leading coefficient, we're going to go back in and fill in a lot of other stuff. Alright, so on the top of our chart there, we've got where our degree is odd. So that could be our highest power could be a 1, a 3, a 5, a 7, some odd number. Then on the bottom, our degree is even, our highest power is even. So it could be a 2, a 4, 6, 8, some even number. That's what we're looking at. We're fixing to fill in a lot of more stuff there. Alright, are y'all ready or do I need to wait a second? Alright, my first square up here. My degree is odd and my leading coefficient is positive. Those are pluses and minuses. My leading coefficient is positive. That means that my graph, and this is just going to be a generic graph. This is not going to be precise, but it's going to cover everything that I'm looking at. I'm going to draw something that looks similar to that. Okay? And here's what I know. This is what you're going to know. My degree is odd. Anytime your highest power is odd, the ends are going in opposite directions. Okay, if you think about a line that's so first power, right? 2x plus 7. Its highest power is 1. Line's ends go in opposite directions. So anytime it's odd, so that means both of these up on the top are going to go in opposite directions. Now this one was positive, so it went uphill first. Okay, so since this one's negative, it's going to go downhill first. So it would look something like just the opposite of that. Opposite directions, but it went downhill first. Okay, so odd, they go in opposite directions. It's like a lightning bolt going in opposite directions. Now, I'm going to add some fancy symbols in there with these now. Woohoo! F of x, remember, is another way to say y. So over here on the right side of this, as f of x is the y, an arrow like that, that reads in math as approaches. So as f of x approaches positive infinity, means it keeps going up forever, positive infinity, x approaches positive infinity. Okay, because the farther this keeps going up, it also keeps going to the right. Okay, so over here on the left side, it's going down, so f of x or y is going down. That means it's approaching negative infinity. The farther down it goes, the farther left it goes. So x would also be approaching negative infinity.
So it's both of those, like?
Because you got to know what happens on the upside and the downside.
So two separate things at once. Are we going to have some examples on these?
So over here, ready to go to the second one over here? Let's do we'll stay on the left side. This is going up on the left side, right? So that means my f of x is going to positive infinity. So f of x is approaching positive infinity. The farther this goes up, it keeps going to the left, doesn't it? Left on my x is negative infinity. The farther up this thing would go, it would keep going to the left. So as it y goes to positive infinity, x goes to negative infinity.
Okay, it's on that side of the graph, right?
It doesn't have to do with what side of the graph it's on. It has to do with where it's going. It's going up and left. Up's positive with the y, left's negative with the x. So if I looked at the downside, as the y is going down, as f of x is approaching negative infinity because it's going down, the x keeps going to the right. To the right on the x is positive infinity. The farther down this thing goes, the more to the right it also goes. And to the right is positive and positive for x's.
How come on the other one they were both the same? Like negative, negative, positive.
Well, because this one went down and left are both negative. Up and right are both positives. But it flipped it over there. It's going left and up, that's positive and negative. Down and right, that's positive and negative. Alright, here's two examples for your bottom graphs. This first one over here, both of the ones on the bottom, first off, degree is even. So if I've got an even degree, 2, 4, 6, 8, that means your ends are going in the same direction. So that's when you get to make the touchdown symbol. Both of the ends are going in the same way. So touchdown, three-pointer, whatever you want to call it, the ends are going in the same way. If it's a positive, that means you're going up. And you should remember that because of the parabolas that we've been doing for the last month. Parabolas are squared, bless you. That's an even. They open going in the same direction. Okay? Fourth power, you could have a little extra bump in there. Looks like a W or an M or whatever. Even, same direction. If it's positive, it's up. If it's negative, it's down. Okay, so that's the difference that you've got on those. Now to get our fancy symbols in on that one. On this one here, my y, it's going up on both of them. So as f of x approaches positive infinity, so as this keeps going up over here, what does x keep doing? Where does it go? It's going to the left, right, which is negative infinity. But on this side, as my y keeps going up, f of x approaches up is positive infinity. On this side, what do the x's do? They're going to the right. So that is positive infinity. So y's only go up on this. X is negative over there, negative when it goes to the left and positive when it goes to the right. So on this side, y's are only going to go down, right? Farther down this one goes, f of x approaches negative infinity. Where's the x going? So negative and negative on that one. But over here, as f of x goes down to negative infinity, x goes to the right, doesn't it? Which would be positive infinity.
So, like on these, will I give you a graph?
I can, or just an equation. Because we could look at the equation and know the degree where it would fall and the leading coefficient where it would fall.
So the equation for like the top left one would be like a positive x to the third.
Alright, y'all got your chart done, what you need? That's all I'm going to add on it. So break out what you need there on that. Alright, let's say I gave you f of x equals negative 0.5x to the fourth plus 2.5x squared plus x minus 1. The directions say describe the end behavior of the graph. Alright, so first off you got to know what square you're looking in before you can describe the end behavior. So is my degree odd or even? It's even. I got a 4 as my highest power, so it's even. So I know that I'm looking on the bottom half of my chart, right? Is my leading coefficient positive or negative? Negative. So I'm on the bottom right side of my chart, right? Everybody got there? Okay, so the bottom right side, what does it tell us about the end behavior? As f of x approaches, which way are you going?
Sorry, I didn't get that.
Me neither. So f of x approaches negative infinity. What does x do? It does one time, yeah. And then on the other side, f of x approaches, it's still negative because they're both going down, right? But now what will x approach? Yep, that's it.
So you just find the degree and then the coefficient.
How can I not do anything? Mine was like,
Sometimes I have good ones, sometimes I have bad ones. This one here was pretty good, but the rest of them were bad.
those were good for me.
Okay, so basically all you got to do is read your chart there and plug that in. Alright, now, go do some real fun. We got what you need off that one? Oh, my bad, I'm back. Oh, David, you're always being negative, Nancy. Alright, we're going to actually graph one.
Is this enough room?
Yeah. Alright, we're going to graph f of x equals x cubed plus x squared minus 4x plus 2. Alright, so this, I'm going to make an old school input-output table. I'm going to always do a couple, I'm plugging in, picking my favorite x's, but I'm going to always plug in some on the negative side, I like 0, and some on the positive side. So that's going to be my starting spot. I'm going to try plugging those 5 numbers in. Sometimes I'll have to plug in more. That didn't give me a good picture of the graph. Sometimes it gave me everything I needed. So I just got to look at it and see. So if I start with that -2, I'm going to plug that in everywhere the x is and evaluate like we did earlier when we did a 3. We just got to do that 5 times now. Okay, so I'm going to have -2 cubed plus -2 squared minus 4 times -2 plus 2. So that's -8 plus 4 plus 8 plus 2. So that's 6. Did I get a 6 on that? Okay, now I got to do the -1. So that's -1 plus 1. That's 0. Plus 4 plus 2. So I got a 6 again. Is that right? 0 is easy because that's 0, 0, 0. You're just left with a 2. Alright, but my 1 cubed plus 1 squared minus 4 times 1 plus 2. That's 1 plus 1 is 2 minus 4. 2 minus 4 is negative, so that's 0. Now tell me if y'all get something different than me on any of these. And then my 2. 2 cubed plus 2 squared minus 4 times 2 plus 2. So that's 8 plus 4 is 12. Minus 8 plus 2. 12 minus 8 is 4. Plus 2 is 6.
How do you know if it's good or not? Like, you said it might be good.
I'm gonna plot those points and see if it shows me enough. You know, what if they were all just right next to each other, I wouldn't see a whole lot of it. Alright, since I think my reds only have 5. Yeah, so I'm going to count on every line, so I've got enough to get up to my 6's up there. So -2, 6, -1, 6, 0, 2, 1, 0, and 2, 6. All right, now if that's all the info that I had, I'd probably draw a pretty bad graph on this. But we're going to look at that function that I wrote up there in the beginning, and we're going to figure out which quadrant of that chart it would go in to know a little bit more about it. What's the degree, odd or even? Odd. It's x cubed. 3 is odd, right? So it's odd, so I'm on the top half. My leading coefficient, is it positive or negative? It's positive because it's a 1, positive 1. So it's going to be that top left picture, right? So that means it's got to go, end's got to go in opposite directions, and since it's a positive, it has to go up first. So I don't want to just start on that point that I have on the very left. I have to go up to hit that point, don't I? Y'all thinking ahead with me? See what I'm thinking? Now I also know that I didn't have anything that went straight across. So I'm not looking at drawing a line there. If I start from the left and I go up to hit that point, it's probably going to do something along those lines, isn't it? Would that, if I hit the point, would that meet the criteria of that graph? That's it.
Oh, so you just start your line down and press that?
Now you could hit y equals on your calculator and type all that in and look and see what it looks like on your calculator. And then you can even go to your table and check those points that I used. See if all those are right. Not bad at all. My graph there is just a guess?
Yes.
Oh, yeah, that would be. I mean, mine's not precise, so that I was going to go with you on that. It would be, yes. Did you get it on your calculator, Kylie?
Yeah.
Looks similar to what we got? Yep. Good job. Good job.
Wait, what do you have to put yes for?
There's polynomial function.
So, wait,
Go ahead.
I was gonna ask how we would know, but it's the same way as how we would know if it was just. It's not too hard. It's not too hard.
It's not. This should be, I would imagine that just the stuff we've done today should be easier than the quadratic stuff that we've been doing lately.
So it's complicated.
It's not too bad at all. Now where we go from here, it's not any harder than that. We're just going to look at combining them, like adding, subtracting those functions, multiplying, dividing. It's just combining like term stuff, and you've done that since about the 7th grade. So they'll just have higher powers is all. All right, any questions on any of that? Because I'm going to give you one to try and make sure you can get it all. All right. This one says h of x equals 7x to the 7th plus 12x to the 5th minus 6x cubed minus 2x minus 18. Okay, here's everything I want to know. Is it a polynomial function? If it is, its degree, its type, put it in standard form if it's not, and describe its end behavior. So it's everything we've done today minus the graph. Okay? Go.
How do you know what the type is? Because it's 7.
Well, we don't got a special name for that, do we?
No.
We'll just, I could make up, is it hepta? No, that's 6. I don't know. Just leave, since it's 7th, just write 7th again. I don't know a fancy name for that. I didn't think of that when I wrote type down. Sometimes. Bless you. Leading coefficient. I left that off the list. Tell me the leading coefficient. Where did you get that from? So is that the right square being?
How would that, since there's 4 different answers, you have to specifically
Well,
say
there's
like
not.
on this side?
This is one.
Oh.
So there's just 2 different answers.
Oh, so as long as you have them going with the right one, then
Yes.
it doesn't matter?
Yes.
Because it's part of the.
All right. Is this a polynomial function?
Yes.
Yep. Good job.
So if it was no, we wouldn't have to put
Right.
anything.
If it's no, you're done. What is our degree?
7.
7. I didn't have a fancy name for that. What's our? I'm going to write this down here. What's my leading coefficient? It's also 7. Just coincidence that it was a 7 out there. Standard form. Already is. You didn't have to change anything. 7, 5, 3, 1 constant. Okay. In behavior, as f of x approaches negative infinity, what does x approach? Okay. As there's your first one. That's what Macy was asking about. That goes together. So here's my second one because it's got 2 ends. As f of x approaches positive infinity, what does x do? Positive infinity. That's it. Good job.
That's pretty simple.
Yep.
I
I like
have
it.
to look at that graph.
Yeah. Yeah. And you'll be able to use that whenever you need it.
Okay.
Yep. Very good.